Data enthusiasts, today's session is with Evgeniy Savin. He is Head of Data Science and Analytics Education at Spiced Academy across Berlin and Neue Fischer across Hamburg. These and that is the Data Science and Web Development Bootcamp for those looking to transition their career into data science. So we had a great conversation focusing on the fundamentals of data science and the essentials needed to help you transition your career into data science. We also talked about some of the specifics of tech skills and soft skills, and we talked a little bit about the direction that data science is going into. So if you want to transition your career into data science, check out the podcast. Evgeny, what are the biggest misconceptions people have about the role of a data scientist?
Well, I think the central misconception that people have is that a data scientist is somebody who builds machine learning models from scratch and spends majority of their time optimizing performance of a machine learning model. So, squeezing out the extra 10% of performance. I think, if you go on a Kaggle competition, that's basically what you do. You get a clean or a relatively clean data set. You create a model of some sort, and then the goal is to outcompete all those other teams that might have done something similar to you. Now, in real life, in a business setting, that's not what the day-to-day life of a data scientist looks like.
Nice. Well, with that, thank you for busting that misconception. What's then the reality, the day-to-day life that you mentioned?
Well, I think I can summarize it with a little joke. That 80% of data science is spent cleaning the data, and 20% of the time a data scientist moan about needing to clean the data. So I think that's much closer to the reality of data science work. I think the real challenge, even before we come to cleaning data, is convincing the stakeholders that they might benefit from a machine learning solution or a data science solution of some sort. I think that's the first biggest challenge to overcome.
I see. My apologies. My audio cut out there, so I couldn't really respond in the moment. Interesting. Okay. Today's topic for listeners and viewers is about becoming a data scientist. And of course, Neue Fischer and Spiced Academy helps people who want to become a data scientist or a developer to become one or transition their career into one. If I was to take the course, what would I learn to help me become a data scientist? And also, what should I focus on?
Okay, so let's imagine, Joseph, that you decided to become a data scientist. The first question, of course, is how did you decide to become a data scientist? Why data scientist and not why data analyst, and why not a data engineer, and so on. I think the reality of it is that majority of people who come to our bootcamps don't really know what the difference is. We provide some advisory on the differences between these data professions. So how data analyst differs from data scientist. But fundamentally, I think for many people, doing either bootcamp is their first experience of tech, of tech as an industry. So it would probably be something similar for you. Probably, I mean, you're working for many years in recruiting, I guess, and you're doing this podcast, so you probably have some experience, some ideas about what the tech industry is like. But maybe actually working in it and sort of contributing code and so on and creating models is something that you've never actually experienced. Right. So to make you a data scientist, we would have to first teach you the fundamentals of collaboration. How do you collaborate with others in a tech environment? So we have to start with Git, or a version control system. We have to explain why Git is such a central piece of today's collaboration. And we have to do it in a fairly convincing and simple manner. Then we would have to address the second question. What is Linux? And why are Linux machines so important for the tech industry? Why those good old trustworthy Windows machines that some of our participants come with don't cut it when it comes to running server software. And these are very fundamental questions, and we have to answer them first, because if we are going to prepare people for a job in the tech industry, they need to understand those two things. Then, when we are done talking about those two things, we need to choose a programming language. And there are many programming languages out there, and the one we teach is Python. So we have to answer the question why data scientists should be trained in Python. Why shouldn't they be trained in R, for example? Why shouldn't they be trained in MATLAB or Java or so many other languages out there? And the answer to that question is because Python is a general purpose language, and we are preparing people for career in the industry. So they need to be able to collaborate with others. And Python being so general purpose and so vast allows others to read your code as a data scientist, and it allows others to basically interface with your code. Is it possible to do it with other programming languages? Of course. I mean, I spent quite a long part of my career writing code in R, and I really love my R. But when it comes to deploying, when it comes to creating services for external consumption, so when it comes to taking this code and using it not just on my machine, but making it available for clients, external or internal, Python has won the game. Every major cloud provider has some integration to Python. So I think this would be the first three questions we would address. We would try to convince you that these are worthwhile things to learn. And of course, we would also teach you some SQL. So we would teach you about databases. After all, you're becoming a data scientist, so you need to be able to interface and query those databases. You need to be able to work with relational databases. We would have to discuss why relational databases are so prevalent, what other types of databases are there. Yeah, and we would have to try to convince you that relational databases is something that you're very likely to encounter in your career as a data scientist. Yeah.
I like it. Thank you. It's a great nutshell there, and good for me when I transition my career. So collaboration, how to work with Git version control, Linux, an overview of, and Python. It's an interesting one about Python because many of the data scientists that come through the academic path will have used R. So they will be transitioning as well, but perhaps an easier transition for them because they've used a tool that's similar. I understand Python is a lot more sophisticated and thus its capability is stronger. Okay, and then of course SQL, which every data person, data science or otherwise, will have a handle on. All right, I'm a data recruiter, unlikely to make a move into data science, but it's not unheard of. We often hear about marketing analysts and software engineers, to take two examples I can think of, about people transitioning. What other roles or industry areas do you see people transition into data science from?
So we work with people who usually transition from a completely different career path. So we work with quite a few academics that come through either a master's or a PhD program, where they
In what areas?
chemistry, biology, physics, Spanish literature,
Nice.
all sorts. So generally speaking, it's more quantitative areas. So people would normally have some quantitative background, but not necessarily strong coding background. In fact, having worked with many PhDs, I think our bootcamps would revolutionize academia. You know, if we could offer them to every PhD coming to us, if we could offer it before they start their PhD, I think we would create an amazing impact on the world of academia, because we would teach them all these things about collaborating in a kind of a contemporary way, using Git, writing clean code, having code reviews, and so on. But this is just a segment of our students. Other segments would be just people changing their career. I had a few project managers and product managers who wanted to understand more about machine learning and AI. They wanted to kind of have in-person experience of working with these fields, so that they can collaborate better with data scientists. And of course, as you say, the software developers, marketing analysts, and so on. Those are some of the people that we meet too. Yeah.
Okay. So the ones that I mentioned, engineers and marketing analysts, they seem like more of a linear path. You also mentioned people from a quantitative or mathematics background. Again, that seems like a more linear path. And then product and project managers, quite different. My next question was going to be, how do you know if you were born to be a data scientist? Or do you think you are born to be a data scientist, especially given what you've said about that statistical or quantitative background?
I think there are some people working on the bleeding edge of technology, creating models for OpenAI, and so on. And I think it takes a lot of motivation and talent to make it there, to make it into this type of positions. But I think beside that, in every organization, there are challenges which are much more modest, much more humble type of challenges, which can be resolved by more traditional machine learning methods. And I wouldn't say that you need to be born to be in this profession. I do think that you can learn it. I have also learned it by doing. I have not graduated with a degree in data science or machine learning. So I think you do need to have motivation, and you do need to love looking at the code, looking at the data, scrupulously studying it, finding questions. You need to have a strong desire to spend a lot of time in front of a computer screen alone. Sometimes banging your head against the table because it's difficult and it's tough and you don't know what to do. So if you have this type of motivation, there is enough literature, and there are bootcamps like ours that can basically teach you the fundamentals of those methods you'll be using. You might be interested in exploring their mathematics completely fully, and for that there is also enough educational resources. But as long as you understand the fundamentals, you can apply those methods and you can use them effectively.
So before taking on a boot camp, you could or should invest your time and training in some kind of mathematics qualification. Did I understand that correctly?
No, that's not required. That's not required. It certainly helps to have some mathematical background. We in the bootcamps, we do go through all the math. We don't solve all the equations, but we show the math and we go through all the basically algorithms and conclusions. And of course, if you have a mathematical background, those things are easier to grasp and they're easier to understand. And if you don't have this background, you can sort of not necessarily get into detail, but just understand how the method works, and maybe come back to math sometime later. It's up to you.
Okay.
It helps, but it's not. We don't require you to do like university preparation before you come into the bootcamp. But it certainly helps to have some mathematical background. Yeah.
Okay. Good to know. Would it help to have any other particular hard skills?
Coding
skills.
Coding skills are very helpful if you have experience coding in any other language. Then it's certainly helpful because you then have the ability to resolve your own problems. You know about Stack Overflow, you know how to read error messages, you know how to read help files, right? And kind of proceed when your code breaks.
Yeah, okay, so coding skills would help you with the contextual stuff involved with being a data scientist. All right, how about, given what you said about being able to sit in front of a computer screen on your own for hours, challenging very frustrating mathematical equations or problems, what about moving away from that element and the people side? What people skills are going to serve you well in taking on a bootcamp or transitioning your career into data science?
Well, here it's very important to be able to work with people, of course. So we have quite a few academics coming, and in academia you don't necessarily share your work with others because you're afraid they will basically take it and publish it under their name, right? So sharing your work and sharing your mistakes is something that's not necessarily encouraged. First thing we need to address is exactly this. When people come into the bootcamp, we on day one explain that they're going to be working in pair programming mode for the duration of the bootcamp, pretty much with different people, and that they will have to review each other's code, so that if somebody makes some mistakes, other people can can spot those mistakes and fix them. And this is, of course, it's a big hurdle for some people to step over, because suddenly, all of your incompetence is exposed, and you suddenly have to show how incompetent you are. And
also have the humility to take on feedback.
Exactly. Take humility and and have trust in your colleagues and your classmates that they will give you good feedback, and they will teach you what they know. So it's a psychologically not a very easy process for many people, but it certainly requires to have, you have absolutely need to have this skill if you're going to work in the industry. I think the most essential part is acknowledging your ignorance. If you're somebody who's working in the industry, somebody comes into a room and says something that you don't understand, you absolutely should ask questions, and if you're not doing it, there might be 7 other people from 10 that also don't exactly understand what this person is talking about, so there should not be a silent kind of consensus around ignorance and around professing your ignorance. Of course, you should try to become better, but nobody knows everything. So working with people, helping others, like also asking for help when necessary, is part of the experience. It's very much part of the experience. And also, of course, being able to communicate your findings with people who are not technical. So all the presentations that we have in the bootcamp, they are all geared for non-technical stakeholders, for your business counterparts in sales and marketing, and for your C-level, perhaps future C-level. Yeah.
Okay, and this is great preparation for the ultimate position. In the ultimate data science position, what soft skills do you think are most valued?
In the ultimate data science position, I would have to find out what that is, an ultimate data science position. I think there are so many different positions. They are called data science. I think the spectrum is very large. So when I before I started coaching, I was kind of doing machine learning engineering, and the absolute ultimate requirement of that position was to be a good coder and to have extreme attention to detail and quite a good conceptual understanding and motivation to improve the technical areas in the company. My friends were working in the sort of more in the A/B testing, hypothesis testing side, where they had much more communication, much more work relating to defining the KPIs, defining which KPIs are going to be measured and which KPIs a certain feature is going to improve. So I think there's like a spectrum of things, but I think common to them all is a degree of technical aptitude, ability to inspect and look at the data, desire to use data to guide you in your decision making, and ability to express the need for that in simple, accessible language, ability to convince people around you that by using data, by using scientific principles, you eventually will get to better results.
Interesting. I want to take a look at the kind of arc of, or the evolution of the data scientist, maybe from a social perspective. I'm thinking about myself as a recruiter. I've recruited in data science for the last 5 years, and then the 5 to 10 years before that was more software engineering, and there's very little data science around. So I wonder, obviously the demand has changed, but have the skills needed to become a data scientist, have they changed throughout the most recent years? And with that, how will they change in the next 5 years?
Well, that's a tough one. I think
It's a tough one, I know. Yeah, two different questions. Apologies.
I think it's a tough two then, I think from when I was first starting out in data science 7 to 8 years ago, what has changed now is that I think many of the jobs are no longer about just developing the models. It's a lot about deploying them. So there's a lot of machine learning operations and basically doing a lot of things on cloud. So deploying models on cloud. And for that, you need the whole, whatever it is, Google Cloud, AWS, Azure. You need to know the cloud infrastructure. You need to be able to interface with it. You need to be able to understand it. So there's a whole like shift of focus, right? Because I remember like 7-8 years ago when I was starting out, data scientists, they would create a model and then they would translate it or give it to software developers who would then rewrite it in Java or something like this, or in some other language, and that's how they would deploy it. They would translate it into their language that they understand and integrate it into their monolith kind of code, right? Today, you probably are not going to do that. You're probably going to create your own endpoint on cloud, and then you will invoke it, right? So there's like a lot of possibility, a lot more possibility for developing data science products, but also the skills that are necessary are, I think, are different. You need to be able to do a lot of those things by yourself or within the team. And I think, I think in addition, going 5 years in the future, I think the hype around data science might be calming down a little bit. I think we were in a very hyped environment maybe 5 years ago. Maybe here you might disagree with me. Maybe you're recruiting, so you know better. I think many companies understood that without proper data infrastructure, good data engineering practices, good databases, you can't really develop data science products. That data science products, they are like I would say they're like a cherry on top of a cake, and the cake should be made of good, data engineering solid practices, which not many companies invest in. Many companies, being startups and scale ups, sort of rush through the stage, and their databases are a mess. And if your data is a mess, you can't really do anything with it.
Yeah, I think that's still recognized as best practice to have your data infrastructure set up so that you can build analytics and data science on top of that. But as you say, startups don't have the time or the financial resource to set up all that infrastructure. But yeah, it would be an ideal, is my understanding of how companies want to work. Yeah. Okay. What skills do you think will be most in demand for a data scientist in the next 5 years? We've talked about SQL, we've talked about Python, MLOps generally, DevOps to some extent, maybe. Yeah, what other skills, hard tech skills or soft skills?
So I think, like with everyone else, generative AI will be present, but I think it will be present in every tech profession. Knowing how to work with generative AI, asking the right questions, giving the right prompts, can significantly boost your productivity. Actually, we are integrating now into our course generative AI, and we kind of hope that it will become almost like Git, so that people will day-to-day use this things that we're going to teach them in the first few days about generative AI and prompt engineering. I think the fundamental understanding of machine learning models is important. I think it's not going to go away. In the industry, I think there is space for just saying, I don't care how those things work, as long as they, as long as they output some predictions that I can use. I don't care what's in this black box. I don't mind. There are libraries for that, called AutoML or stuff, where basically you just try every algorithm in the book on a certain data set and choose the one that works best. But I think if you understand what's inside this black box and how these algorithms works, you clearly have an advantage. Very important, and I think most important, is understanding where to apply machine learning and why. What are you trying to achieve? So if you are creating a machine learning model, and let's say it outputs a prediction of some sort, the question is, what are you going to do with this prediction? Right? How do you go from a point of, okay, I have a prediction of some sort or classification of some sort, to I made so many euros or dollars from that prediction? So product thinking, what is the product? Why this prediction is beneficial or useful? Right, and then I would say if you cover those three and you have a product, you say, okay, I've got a product, I've got a model, then you come to a point where you have to start thinking about deploying it, so going on cloud or going on some infrastructure hosted in-house, putting the model there, creating an endpoint, somehow making it work with the rest of the engineering components in the company, then monitoring the model that you've deployed, making sure that it's running the way you expect, making sure that it's outputting correct predictions in the right latency, and so on and so forth.
I like it. Product thinking, an understanding of Gen AI, of course, machine learning, and then invest in or investigate deployment, how to and where to. Okay, so these are solid foundations, if you will. I wonder, given time and recognizing that you've already given us so much information about how to transition your career already, for the juniors coming up into data science, or those transitioning their career, what final piece of advice would you give to these folks who want to become data scientists?
I think it's possible. I've seen many examples of people who have done it. I don't think it's glamorous. So be prepared to face the fact that it's not glamorous. But I think the profession itself is interesting, and if you enjoy technical work, if you enjoy creating and helping create new products, there is a lot of demand and a lot of space for you there still. And it might not necessarily be in Google or Amazon or Nvidia. These are really the bleeding edge companies, but there are many companies in Europe and especially in Germany which are very much behind on that, and there is a lot of potential and space there for using machine learning and optimization of all sorts.
And that will continue. There is oodles of opportunity, lots and lots of it. So recognize that it's not a glamorous profession necessarily, but it's an extremely interesting one, and there's an opportunity for the modern data scientist to have a great impact on an industry and on the product set that they're working with. Are there any other pointers you'd give us, any points of advice for the professionals transitioning?
No, I think having a general read about the tech industry, understanding what kind of roles there are in the tech industry, is a good starting point. I've had people who came to a data science bootcamp and became product owners afterwards. They liked the industry, they liked the way the industry is, but they didn't necessarily want to be data scientists. They did the bootcamp and they said, it's not me sitting in front of a screen and coding the whole day. So I think answering the question why tech industry is something I'm interested in and what sort of job am I looking in it for is important. I would recommend that. And then if you think data is your thing, then data science and data analytics are two things that you should consider. Yeah.
Fantastic. Okay. Evgeniy, thank you very much for your time today. I really appreciate it.
You're welcome. Yeah.